The following is Summer 2009 Math 263 Test 3 number 8. This is 6,8. Now, consider a solid in the first octane with density is equals to xyc, bounded by y equals x squared and z squared plus x squared equals 2. Notice that this boundary here is same to the one we see in number 7. Okay, now let me quote that again. This is the situation in number 7, and the solid looks like this. Okay, now that's the situation. Now let's see. Now we will now compute the volume. Now the volume is free from the density. Okay, now then to find the volume, what I can do, I will use one of this integral that we have in 7b, right? I think this time I will do it in 2 different ways. I will show you the regular choice that we made, which may not be the easiest one. We will do the first one here, okay, and the second one I think I will use this one. Now why I choose this one? For my, let me pull it down. This one is the regular one, this is the first way of doing this. Okay, most people try to do it this way first, but I want to point out that actually another way to do that is either one of these two, which seems to be easier, because notice that this is actually a quarter of a circle, right? A quarter of a disk, to be more precise. And you will see that the domain later on, the domain that we have here later on, we will be able to convert that into polar integrations. Okay, now let's start using the regular way, the standard way that a lot of people choose first. If you choose that without thinking, then you will tend to do the first one. The volume equals to integral from 0 to radical 2 0 to x squared and 0 to square root of 2 minus x squared. Now if you wonder how I get this one, I get it from here. You can see my solution to number 7 again. That's how I get that. Okay, dc dy dx, this is equals to integral from 0 to radical 2 integral from 0 to x squared. That will be square root of 2 minus x squared dy dx. And then if I integrate respect to y, I will get, because it is the integrand is independent of y, then it will be just the length of that interval, which is square root of 2 minus x squared times x squared dx. Okay, now then from here I think we will use some kind of trigonometric substitution. Notice that if I substitute my x by radical 2 sine 2, the sine theta, then my dx equals to radical 2 cosine theta d theta, right? And then my integral right now, when the x is 0, my theta is 0. When my x is radical 2, my theta is pi over 2. Now this part here later on will become, I think that will be radical 2 cosine theta, right? And then the x squared will be 2 sine squared theta, and then the dx will be radical 2 cosine theta d theta. Now if I put them together, this is integral from 0 to pi over 2 4 cosine squared theta sine squared theta d theta, and it happens to be a nice one, 0 to pi over 2, integral from 0 to pi over 2, and I will put this together, 2 cosine theta sine theta squared. I hope you know where I'm going to. This is equals to integral from 0 to pi over 2. The guys inside is actually sine squared 2 theta d theta. Now from here I do half angle. I hope you remember that. This is 1 minus cosine 4 theta over 2 d theta. Am I okay? Think about it. Right? Now then this is equals to integral from 0 to pi over 2 of 1/2 minus cosine 4 pi over 2 d theta. Now then the first term here will be 1/2 times the length of the interval will be pi over 2, 1/2 times pi over 2, and the second term, if you think about this, notice that this is the period of this is pi over 2. In other words, if I integrate that from 0 to pi over 2, it will be 0, right? But let's prove it. This is minus integral of cosine is sine pi over theta over 8 from 0 to pi over 2 pi over 4 minus when theta is pi over 2, sine, this will be sine 2 pi, which is 0. When theta is 0, sine 4 theta will be also 0, right? Or you get this is the following. Now alternate way to do that, like what I promised you earlier. Alternatively, I will look at the one here. Okay, I will use either one of these. Let me use this one. Integral the volume equals to integral from 0 to square root of 2, integral from 0 to square root of 2 minus x squared, integral from 0 to x squared dy dz dx. Okay, now why do I like that? Because of this. If this is my x and this is my z, you can change this into polar with certain substitution. Okay, now the one here, it will be x squared, right? Okay, now but if I change it to polar, let's say x equals to what is that, r cosine theta, and the y is r sine theta, then you z equals to r sine theta, then you will see that the theta will be from 0 to pi over 2, and the radius will be from 0 to radical 2 of x squared, which becomes r squared cosine squared theta times r dr d theta. Okay, and notice that the domain is quote unquote the rectangle and the integrand is separable. So let me separate that. I have integral from 0 to pi over 2 of cosine squared theta times integral from 0 to radical 2 of r cubed the I mean this is the theta here and this is the r. Now I have a little trouble here because of double integral, not double integral, I mean half angle. This is 1 plus cosine 2 theta over 2 d theta times this is 1/4 r to the 4th from 0 to radical 2. Now the one here, there will be theta over 2 plus sine 2 theta over 4 from 0 to pi over 2, and this will be 1. Okay, times 1. Now here when I plug it in, there will be pi over 4 for the first term, plus the second term will be 0, right? Sine pi is 0 minus sine 0 is also 0. Times 1, you will see eventually that this is pi over 4, the one we get earlier. Okay. Now, let's take a look on the mass of the solid. We expect this to be long, and I wonder what do you have in mind, which one you would like to use. Let's start with this. Let's say the mass equals to, seems like that integration is easier, huh? Don't you think so? Okay, and that's what I will use then. The mass equals to integral from 0 to radical 2, integral from 0 to square root of 2 minus x squared, integral from 0 to x squared, and then inside I have x, y, z, dy, dc, dx. Okay. Hopefully this is easier. Let's see, then this is equals to integral from 0 to radical 2, integral from 0 to square root of 2 minus x squared, and this will be 1/2 xzy squared from 0 to x squared dc dx. This is equals to integral from 0 to radical 2, integral from 0 to square root of 2 minus x squared, then you pull the 1/2 out, and xz, y replaced by x squared, so y squared will be x to the 4th dc dx. This is c x to the 5th dc dx. Right? Now, it seems like it's not really that hard for us to integrate these respect to z. Let's see. If I integrate the respect to z, I will have, so it seems like I don't need to really change it to polar, huh? Let's see, there will be 1/2 x to the 5th z squared from 0 to square root of 2 minus x squared dx. I replace the z by square root of 2 minus x squared, therefore the c squared will be 2 minus x squared. I pull the 1/2 out, becomes 1/4. Seems like it's not bad. Continue further. This is, I hope you see this to be Mickey Mouse right now. This is 1/3 x to the 6th minus 1/8 x to the 8th 0 to radical 2, therefore this is 1/4 times 1/3, and this is 8 minus 1/8 times what is that, 16, right? So 1/4, 8/3 minus 2. Okay, but the inside here is 2 touch though, so this is equals to 1/6. Okay, now of course you can try to do it using the first domain here, first way. Of course you need to insert xyz there, right? But we expect to see the same answer at the end. Okay, this is for summer 2009 math 263 test 3 number 8.